Okay, guys, unfortunately, when we did the fundamental theorem of calculus, we had to shorten that up a bit, and we did not get a chance to do the net change problem, which is something that you need to know. This will be on the AP test, okay? And so I need to expose you to this, and I just got a little mini lesson here just on this, and it's got a couple of problems for you to try. So the definite integral of the rate of change of a quantity f prime of x gives the total change or the net change in that quantity on an interval ab. So the integral from a to b of big F prime of x dx equals f of b minus f of a. All right, what does that mean? So let's look at an example here. A chemical flows into a storage tank at a rate of 180 plus 3t liters per minute, where t is the time in minutes and 0 is less than or equal to 60. I'm sorry, 0 is less than or equal to t is less than or equal to 60. Find the amount of the chemical that flows into the tank during the first 20 minutes. Okay, so we want to find the net change in that amount of chemical over that period of time. All right, so here's what we're going to do, is we're going to take the integral from 0 to 20, because it's the first 20 minutes of the rate of change, 180 plus 3t dt. Okay, so this is going to equal 180t plus, let's see, it's going to be t squared, and it's going to be 3/2. Okay, evaluated from 0 to 20. So we're going to go ahead and plug in 20 here. So it's going to be 180 times 20 plus 3/2 times 20 squared minus 180 times 0 plus 3/2 times 0 squared. All right, this is just 0 over here, so we don't even really need to do this part. It's just 0. Okay, this here we can figure out very simply. 180 times 20 is 3,600. Plus, this is 400 times 3 divided by 2. That's 600. Okay, and this is going to come out to be 4,200 liters. Okay, so that's the change in the amount of liters. That's how many liters of the chemical are going to go in the tank in the first 20 minutes. So not real difficult. Okay, so another way to illustrate the net change theorem is to examine the velocity of a particle moving along a straight line where s of t is the position at time t. Then the velocity, remember the velocity is the derivative of the position function. So the integral of the velocity, I'm sorry, I forgot something here. This should go from A to B. Okay, the integral from A to B of the velocity is going to be the position of B minus the position of A. The definite integral represents the net change in position or the displacement of the particle. So displacement is the net change in position. Okay, keep in mind, this is really important because depending on how the question is worded, you're going to do entirely different things. There is a difference between the net change and the total distance traveled by a particle. So let's say I had something simple, like I had a straight line, and this particle was following a straight line. Okay, depending on what the velocity is, it could be moving away from me, and it could be moving back towards me part of the time, and then it could be moving back away from me again. So you can see that the displacement would be the distance from here to here, but the total distance would be this plus this again. Okay? So they're two entirely different things. Okay, so for example, let's say this was a position function right here. Okay? So this has a positive velocity, and then it has a negative velocity, and then it has a positive velocity. So if I wanted to find the net change, I would take the integral of this, I would subtract the integral of this area, and add the integral of that. Okay? But if I want the total distance, I need to take the area of this, take the absolute value of this, and add that, and then add the third. So they're going to be two entirely different things. Okay, so here we have solving a particle motion problem. The velocity in feet per second of a particle moving along a line is v of t equals t cubed minus 10t squared plus 29t minus 20, where t is the time in seconds. Okay, what is the displacement of the particle on the time interval 1 is less than or equal to t is less than or equal to 5? Okay, so here's what we're going to do. We're going to integrate v of t dt. So it's going to be the integral from 1 to 5 of t cubed minus 10t squared plus 29t minus 20 dt. Okay, so that's pretty simple to integrate. This is going to be 1/4 t to the 4th minus, let's see, t cubed, so this will be 10/3 plus 29 halves t squared minus 20t evaluated from 1 to 5. Okay, so we go ahead and we plug 5 into there, and we plug 1 into there, and we subtract those, and that comes out to be 32/3. Okay? I'll let you kind of figure that out yourself. So that's the displacement, and that's in feet, by the way. So not quite 11 feet, 10 2/3 feet. Okay, now what is the total distance traveled by the particle in this time frame? All right, so this is a different thing. So this is the graph right here. So this thing has a positive velocity from 1 to 4. Is it seconds? I think it's seconds. Seconds, yeah. And then it has a negative velocity from 4 to 5. So here's what we got to do. Is we're going to take the integral from 1 to 4 of what is it? T cubed minus 10t squared plus 29t minus 20 dt. And then since this is negative and we need it to be positive, we are going to subtract the integral from 4 to 5 of this same thing. Okay, so we're going to get the same integral that we got here. I mean, if we integrate it, it's the same thing. So this is going to be 1/4 t to the 4th minus 10/3 t cubed plus 29 halves t squared minus 20t evaluated from 1 to 4. And then we're going to subtract from that the same thing, 1/4 t to the 4th minus 10/3 t cubed plus 29 halves t minus 20, I'm sorry, t squared minus 20t, evaluated from 4 to 5. Okay, so we plug 4 in here, and then we plug 1 in here, and we subtract it. And this part comes out to be 45 fourths. Okay, I'll let you figure that out on your own. And then we go over here, and we plug 5 in here, and then we plug in 4, and we subtract those numbers, and that comes out to be negative 7 twelfths. Okay, and then of course, the negatives cancel. We get a common denominator. This would be twelfths. So this would be 135 plus 7 twelfths, which is 142 twelfths, or 71 sixths feet. Okay, so if we get out our handy-dandy TI-84 plus C Silver Edition graphing calculator, 71 divided by 6, this is 11.83 repeating feet here. And then up here, 32 divided by 3 is, technology problem here. This comes out to be 10.6 repeating feet. Okay, so you can see that this thing traveled a total distance of 11.83 feet, and it actually ended up, it had a net change of 10.6 repeating feet. So the difference between total distance and displacement they're totally different things. So this thing had gone away from me, away from me, away from me, away from me, away from me. Then it came back towards me a little bit. Okay, so that's why the total distance is different than the displacement. Okay, so I hope that helps you with that. Expect a question like this on the AP test. Here's a couple of problems I want you to try. Try 95 and 97, and we'll call that good. All right, have a good day.